Look at some exam questions on the topic recurring decimals to fractions. You may have watched the revision video. So now we're just going to look at typical exam questions set by the IGCSE exam board. Here's the first one. Maybe have a go, put me on pause, and then see if you got it right. So typically they do actually give you the answer to these questions and ask you to show using algebra. So we are going to show that 0.254 recurring is equal to 14 over 55. So let x equal double digit recurring, 545454, so we're going to multiply it by 100. Let me write out the 100x again. Make sure everything is lined up beautifully. Decimal point in the same place. Digits right underneath each other. As you can see, as we subtract 99x on the left hand side, all of these numbers cancel with the ones underneath. They become 0, right? 25.4 minus 0.2 is 25.2. Let's make x a subject by dividing both sides by 99. We do not want a decimal within a fraction, so let's multiply the numerator by 10 and the denominator by 10. I haven't multiplied the numerator, let's get rid of that decimal point. I'm going to simplify it on my calculator using the fraction button. Yes, simplifies to 14 over 55, which is the answer. We have shown that 0.254 recurring converts to 14 over 55 as a fraction. Again, put me on pause and have a go at this one. Let's start out the same. Let x equal 0.828. Just the 1 3 that recurs this time because you've got a dot over the 1 and a dot over the 3. So again, it's a double digit recurring decimal. So let's multiply by 100. Just going to take it up here. Let's write the 100x at the top. X underneath. Line everything up together. When I subtract, 100x minus x is 99x. Right, all the digits are the same from this 1 onwards. And I'm just going to use my calculator here. 28.13 subtract 0.28 is 27.85. Let's make x a subject by dividing both sides by 99. Multiply the numerator and denominator by 100 this time, because we do not want a decimal place. Let me simplify on my calculator, and let's hope we get the same answer. Yep, 557 over 1980. Okay, question 3. Again, have a go, put me on pause. I'm just going to write this out in full. It's already given us that x is equal to it. Again, the 4 and the 5 recur here. 100x, 4.545454. Don't try and take any shortcuts. Otherwise, people who take the shortcuts of these types of questions tend to make mistakes. Let's be methodical. Line all the digits up. Where do they disappear from there to there? 100x, take away x, 99x. 4.5 minus 0, 4.5. Make x the subject. Divide both sides by 99. Times both sides by 10. Simplify. Using the fraction button on the calculator, 1 over 22. Now, these next three do become gradually more complicated. Let's start this one out the same. It's just the 5 that recurs here, because the dot is just above the 5. Because it's a single digit recurring decimal, let's multiply it by 10. $10x minus x is 9x. All these 5s become 0. 27.5 take away 2.7 is 24.8. Let's divide both sides by 9. Multiply the numerator and denominator by 10. And then simplify. Gives us 124 over 45. Correct. Now let's convert the 0.2 recurring into a fraction. So if we look, x equals 0.2222, multiply it by 10 because it's a single digit recurring number. Line everything up together. Subtract. 10x minus x is 9x. They would all disappear through here. Make x a subject by dividing both sides by 9. So we have 3 over 22 multiplied by 2 over 9. Multiply the numerators. Multiply the denominators. Simplify. Using the fraction button on your calculator, yes, it equals to 1 over 33, correct. Okay, last question. Now, I rarely see anybody get this question correct. From the years of me teaching IGCSE at Excel, this is a question that really stumps students. So when I first saw it, I thought, well, what does this actually mean here? 0.4x recurring. Well, it could be this. It could be this. We don't know what the x is, but it recurs. We know that x is a whole number between 1 and 9. Find, in terms of x, the recurring decimal. 0.4 x recurring is a fraction. Give your fraction in its simplest form. So instead of letting x equal my recurring decimal, because we already have x involved here, I'm going to let y equal. And just as normal, we just write it out in full, but this time it is with x's. And it's a single digit recurring number, so I'm going to multiply it by 10. If I multiply this by 10, it's 4.x. Okay, let me write it out and perform my subtraction. Line everything up. Now, if I subtracted the bottom from the top, 10y take away y is 9y. What is 4.x recurring? Take away 0.4x recurring. Well, all of these would disappear because x take away x is 0. So we'd be left with 4.x minus 0.4. I don't want to have these decimals. What I'm going to do is multiply everything in my equation by 10. Now, the difficult thing to spot here is, well, we need to make y the subject, that's fine. But 4x usually means 4 times x. Here it doesn't. What does it mean here? It actually means 40 plus x. Let's just see why. Here, the x represents the tenths, hundredth, thousandths. Okay, when we multiplied it by so here again it's the tenth here. We multiplied all of this by 10. So now this, let's just look at this, x represents units and this 4 represents tens, right? Here, this 4 was in the units column. When we multiplied 4.x by 10, it became 4x, but that 4 represents 40. So this 4x actually means 40 plus x minus 4. If that makes sense. Because here the 4 was units, we multiplied the whole thing by 10. So we got 4 tens x units, so it means 40 plus x. It does not mean 4 multiplied by x. And if we just work this out and simplify it a bit over here, 40 take away 4 is 36. Make y the subject. And this is your final answer.